So in this video, we are going to continue our discussion with chapter number 8, which is Introduction to Trigonometry, and we're going to see concept number 8.3, and we are going to answer a very specific question. What is the specific question? What is the value of trigonometric ratios at 5 specific angles? So we want to discover, or we want to rather find out the values of all the 6 trigonometric ratios, okay, all the 6 trigonometric ratios at 5 specific angles. So first let's see what are the 5 specific angles. Okay, so yes, so these are the 5 specific angles which we are interested in: 45 degree, 30 degree, 60 degree, 0 degree and 90 degree. So we are going to discuss these all 5 specific angles in parts. In this video we are going to focus on part 1 by 3, which is our specific angle of 45 degree. So now what I'm going to do is, yes, rather, yes, okay, keep this hidden. Okay, so in this video we're going to focus only on the specific angle 45 degree. In the rest videos we'll see the rest 4 angles. Now for 45 degree of angle, I want to know the value of 6 trigonometric ratios. Now what are the 6 trigonometric ratios? Let's make a quick note of them. So first of all, okay, hold on. First of all, we have these 6 trigonometric ratios: 1, 2, 3, 4, 5 and 6. Okay, 6. Cool. So we know that there are 2 trigonometric ratios which are foundational, okay, and these 2 trigonometric ratios are sine and cos. Sine and cos are our foundational basic trigonometric ratios. The rest 4 trigonometric ratios are derived trigonometric ratios that derive from the values of sine and cos. So I'm going to write them. The third one is tan. Tan is basically sine divided by cos. Then we have sec, which is basically reciprocal of sine. Then we have cosec, which is basically reciprocal of cos, and then we have cot or cotangent, which is reciprocal of tan. Okay, so very important, we want to note that these 4 trigonometric ratios are derived trigonometric ratios from sine and cos. So now when we are finding the value of these 6 trigonometric ratios at the specific angle of 45 degree, all I need to do is find the value of sine 45 and cos 45. Once that is done, these 4 values can be easily derived. Okay, so that's our first step, or that's our first understanding rather, that we will be finding only sine 45 and cos 45 because those are our basic foundational trigonometric ratios. These 4 are derived. Okay, so let's move on to this specific angle 45 degree. So as we know that for any trigonometric ratio discussions, we start with our consideration of a triangle. So I'm going to draw a triangle here, a right angle triangle. Okay, and this is my right angle, which is basically 90 degree. Let's name this point as B, this point will be A, and this point will be C. Now in this video we are going to focus on specific angle 45 degree. So let's start with sine 45 degree. So let's bring it down. Okay. So sine 45 degree is equal to what? That is our question. Okay, so this angle here I'm going to mark as 45 degree. So if this angle is 45 degree and this angle is 90 degree, we all know that the summation of 3 angles of a triangle is 180 degree. Okay, so this also is going to be a 45 degree angle. Okay, so now we want to find sine of 45 degree. Basically we want to find sine of angle A. So we know by definition what is sine of 45 degree. What is sine of any angle? That is equal to opposite side of that angle. Okay, the whole divided by hypotenuse. This is our standard definition of sine of 45 degree. So in this case I'm going to assume A, okay, as our angle of 45 degree. So let me write it down. This is sine of A, which is equal to, now what is the opposite side to angle A? It's BC, and what is our hypotenuse? It's AC. So I'm going to make a note here. It's BC divided by AC. So this is going to be our sine of A, and A is nothing but 45 degree. Now in order to find the value of sine of A, we should know the length of BC and AC. Okay. Once we know the length of BC and AC, we can easily find the value of sine of A. Now closely observe this triangle A, B and C. We can clearly see that this is 45 degree and this is 45 degree. So if the two angles of a triangle are equal, then their respective sides are also equal, because this becomes our isosceles triangle. Okay, this is the very definition, or this is the basic definition of a isosceles triangle. In an isosceles triangle, the two sides and hence the two angles of a triangle are congruent, they are equal. So since by construction we have constructed this triangle ABC such that angle A is equal to angle C, 45 degree, 45 degree. So if these two angles are equal, then this becomes an isosceles triangle. In an isosceles triangle, these two sides are equal or congruent. Okay, so that is our first observation. We have noted it down. Now let's assume, okay, so let AB, okay, so before that, angle, I'm going to write here, angle A is equal to angle C is equal to 45 degree. Thus, okay, AB is equal to BC. Okay, so this is our observation that we saw. Now I'm going to say let AB equal to BC be equal to P. Let it be equal to P. So I'm going to mark here, this is P and this is P. Now we have to find the value of AC. Okay, so we are going to use Pythagoras theorem. Let's zoom out. Yes. So now let's draw a line here. Okay, so using, oops, yeah, so using Pythagoras theorem, we have AC square as equal to AB square plus BC square. Okay. However, what is AB and BC? AB and BC is equal to P. So I'm going to substitute that. So that is equal to P square plus P square, and that is equal to 2P square. Therefore, AC square is equal to 2P square. And now I'm going to take square root on both the sides of our equation. So AC is going to be equal to under root of 2P. Okay, under root of 2P. This is my value of AC, under root of P. Now let's go and substitute this value in a triangle. So we saw that in a triangle, this was P, this was P. We were going to find the value of AC, which we have found out. So I'm going to remove this question mark, and the value is under root of 2P. Great. Now let's come back to our original problem. We were trying to find sine 45 degree. So angle A is 45 degree. So we wrote down sine A is equal to BC by AC. Now I have the length of BC and I have the length of AC. I'm going to substitute here. So let's do the substitution. Okay. So substitution will be BC is P and AC is under root 2P. Okay. So P and P will cancel each other, and that will be equal to 1 by root 2. Okay, therefore this is our sine of A is equal to 1 by root 2. But what is A? A is nothing but 45 degree. Therefore we can say that sine of 45 degree is equal to 1 by root of 2. This is our final answer. Sine of 45 degree is 1 by root 2. So let's go here. Yes, so let's make a, okay, let's make a table. So let me draw a line here, and let's use in fact a different color. Okay, so now let's draw a line here. Yeah, and now let this be let this be 45 degree. Now sine of 45 degree, yes, sine of 45 degree is 1 by root 2. Now we discussed that we have to just find the values of sine and cos. These four can be derived. So sine is found out 1 by root 2. Now let's again come back to this triangle. This is a triangle here we have. Now we want to find cos of 45 degree. So what is cos of 45 degree? Cos of 45 degree will be basically cos of A, or you can even take cos of C, is the same thing. Let's start with cos of A. Let me use a space here. Okay, so let's, yeah, let me draw a line. Okay, now cos of A, which is basically cos of 45 degree, What is cos of A? It is basically adjacent side the whole divided by hypotenuse. Okay. Now for angle A, what is the adjacent side? AB. And what is, okay, first let's write down. So that is AB the whole divided by, and what is the hypotenuse? That's AC. So AB by AC. However, what is AB? AB is P and AC is under root of 2P. Okay. This is the values of AB and AC, and that is equal to 1 by root 2. So thus we have found out that cos of 45 degree is also equal to 1 by root 2. Let's go here and make a note of it. Yes. So cos of 45 degree is also equal to 1 by under root of 2. Okay. So thus we have found out we have found out the values of two foundational trigonometric ratios, which is sine of 45 degree and cos of 45 degree. Both are same, 1 by root 2, 1 by root 2. Now it's time to fill up these four values. So what is going to be tan of 45 degree? So tan of 45 degree is sine 45. Okay, let's write it down. It's basically equal to sine 45 degree the whole divided by cos 45 degree. Okay, as we can clearly see, sine 45 and cos 45 are the same values, so the division is going to be 1. So this is equal to 1. So tan of 45 degree is equal to 1. Now let's continue. What is sec of 45 degree? It is nothing but 1 upon cos of 45 degree, which is basically the reciprocal. So that is going to be equal to under root 2. Similarly, what is cosec? Cosec is 1 upon sine 45 degree, and that is also going to be the reciprocal of sine of 45 degree, and that is again equal to under root of 2. And finally we have cot of 45 degree, which is again the reciprocal of tan of 45 degree. Okay, and that is equal to, as we saw, tan of 45 is 1, so its reciprocal is also the same, 1. So thus we have found out. Let's zoom into the original question. So the original question was, what is the value of trigonometric ratios, all these 6 trigonometric ratios, at specific angle? So we started with specific angle 45 degree. We did a construction of this triangle where angles were 45, 45, 90 degree, and we found out sine 45 and cos 45, which are the basic foundational values of sine and cos, and then these 4 were derived from the above 2 values of sine and cos. So thus at 45 degree, these are the values of 6 trigonometric ratios.